Having learned how to use and adapt the library in the previous videos, it's time to start creating your own styles. To do this, it's important to have a good understanding of how base objects, segments, and generators interact. In this video, we'll learn how to use an L1S generator, a linear generator, to create a facade for our central building. Along the way, we'll systematically go through the key settings that determine how a parametric object is constructed. Before we open RailClone though, let's take a quick look at the source geometry we're going to use. When creating the meshes for a RailClone style, it's important to think in terms of how they'll fit together like pieces of a jigsaw. Here you can see the parts for the start, the end and the corners, and this one here is designed to create regularly spaced pilasters. And then finally this default piece will fill in between the pilasters, the start and the corners. We've included a few variations of the glazed sections so that we can demonstrate different techniques for randomizing geometry and creating patterns in the next video. When using an L1S generator, the axes of the source geometry are oriented so the x-axis follows the path of the spline, the y-axis runs perpendicular to the spline, and the z-axis is vertical, matching the RailClone object's local orientation. In order for geometry to be correctly aligned in the array, it may occasionally be necessary to adjust the orientation of the local axis. And to do that, go to 3ds Max's hierarchy panel and click Effect Pivot Only. You're then able to rotate the gizmo to the correct orientation. Alternatively, sometimes it can be much easier to just rotate the geometry to align correctly to the world's coordinate system and then just reset the x-forms. As well as orientation, another consideration is the position of pivot points. In order for segments to snap together correctly, it's advised to align the segment on the base object using the local pivot point of the source geometry. This is particularly true on the Y and the Z axis, but less so on the X axis where RailClone's automatic mode is often much more practical. In this example, we'll align the segments using their pivot point on the Y axis, and so to ensure they snap together correctly, we'll make sure all the pivot points are aligned on the Y and the Z axis. Finally, a word on materials. There are two ways to handle them. You can combine the materials assigned to the source geometry into one big multi-sub-object material suitable for all the components. This material should also then be assigned directly to the RailClone object. This has the advantage of being previewable in the viewports, but of course it means you have to manage material IDs and a potentially complex material manually. So there is an easier alternative. When you create a new RailClone object, you can simply activate the Use Segment Materials option, which is found in the Style rollout. When this is active, it will automatically use the materials found on the source objects. There's no need to create a global multi-sub object material or to remap the IDs, but the drawback is that the materials won't preview in the viewports. So now that we have our source geometry sorted, and then go to the Style rollout and open the editor. Now the first thing we'll need is a generator, which is the brain of RailClone. It's where we'll define all of the rules that build the style. In this case, I'm going to use a linear or a L1S generator. Next, I need to give this generator a path. I'll do this by creating a new spline node and wiring it to the generator's spline input. You can then pick a spline from the scene. For this example, I'm going to start by using a temporary 3-section path with an internal and an external corner. I find this helpful for building styles before assigning it to my final design. Note that you can also assign the path from the base objects rollout in the modify panel. Now we can start importing the geometry. To do this, you'd add a segment node, and then I'm going to pick the start-end geometry from the scene. Wire the segment to the generator's start and end input. Pick the material from the source geometry, and then assign it to the RailClone object so it's visible in the viewport. Before we move on then, let's take a look at the segment alignment settings so that we can use the pivots we set up earlier. By default, the geometry's bounding box is used to place the segments for all 3 axes. The bottom of its bounding box is aligned with the spline on the z-axis, and the centre of the bounding box is aligned with the spline on the y-axis. The x-axis is a little more complicated. The alignment depends on which input the segment is attached to, but we'll leave this one be. Generally speaking, unless you've got a good reason to do so, I'd leave the X alignment on automatic, and the ones I regularly change are Y and Z. In this case, because the pieces may be different widths on the Y axis, I would change the Y alignment to pivot to ensure that everything snaps together correctly. All of the other segments should also use the same alignment. So to save from having to change this setting every single time, I'm going to clone the existing segment using Ctrl and C and then Ctrl and V to copy paste a new segment node. Now we can pick the default geometry and wire it to the default input. This segment fills the spline between the existing start and end geometry. An important principle that will really help you to get the most from RailClone is to understand where the settings are for each one of these inputs. When you want to control how geometry for a particular input is assembled, you'll always go to the Generator and then open the Rules tab. Here you'll find you've got settings that control the default segments, the corners, evenly segments and markers. We're going to start at the top and look at the default options. So this segment, used in the default input, fills in between the start and the end, the corner and the evenly segments. RailClone has 4 modes to determine how these segments are distributed along a path. First up is the default tile mode. When this is active, the segments are replicated along the path and then they're sliced at the end if necessary. The second option is scale mode, which stretches a single segment along the path to fit the distance between the initial and final positions of a section. Thirdly, we have adaptive mode, and it's one of the most useful. It calculates the number of whole segments that would fit along a path section, and then scales them all equally to fill the available space. This mode always maintains complete segments with no slicing at the start or the end. When this mode's active, the adaptive value controls how much available space should be at the end of a path before another segment is included. This is measured as a percentage of the segment size on the x-axis. And finally, there's count mode, which allows you to specify a precise number of segments that will be scaled between the start and end positions of a path section. Now that we understand how the default segments are assembled, let's move on and take a look at the corner input and its settings. So confusingly, the corner settings can actually also affect the default segments too. So before we add any new geometry, let's take a look at a few parameters, starting with the vertex type dropdown, which allows you to select which types of vertices actually create a corner and which don't. We'll come back to align to path, but below this we have fillet radius. This option allows you to automatically curve any vertices identified as a corner. And then we have the bevel type option. This one often causes a bit of confusion because it only applies to the way in which the default geometry is sliced. It doesn't affect the geometry that we'll wire later to the corner input. You can use one of 4 modes. None disables beveling for the default segments completely. Instead, it will try to bend the geometry around the corner, or if a corner segment is present, it'll stop the default geometry either side. Reset starts the geometry again, so you'll get a full width segment appear immediately after the corner. There's no attempt to wrap the segment around. Extend slices the geometry so that the length of the segment is maintained as though it continues around the corner, giving it an appearance of continuity. And finally, symmetric matches the size of the segment on both sides of the corner. So now we understand that, let's wire in a corner segment. We'll reuse the start-end geometry by wiring it to the corner input, and then temporarily disconnect the default segment so we can better see what's happening. The corner geometry is placed on each vertex, and RailClone is currently attempting to bend it around the corner. In most cases, you don't want to deform geometry in this way, so to stop it bending, select the corner segment and go to its Deform tab and disable Bend. And now you can see that RailClone is rotating the geometry to bisect the angle of this corner. Alternatively, you can align the geometry to the previous spline section, the Align to Path option. This is mainly useful for corners that are the same size on the X and the Y axis. For example, it works particularly well for things like fence posts. In that scenario, I'd turn on Align to Path and change the bevel mode to none to stop the default geometry from continuing through the post. But for our facade, we want to bevel the corner segment, and to do that you check the Bevel Corner option. When this is enabled, the segment is repeated on both sides of the corner, and then it's sliced to maintain its full length on the outside of the corner. You can adjust the slice position using the BC offset parameter. Plug the default geometry back in, and you'll notice that with Bevel Corner enabled, the default segments no longer continue to the corner, although the bevel mode is still taken into consideration. In most cases though, you'll probably use adaptive or scaled mode, which removes corner slicing for the default segment completely since only whole pieces are used. Okay, so now that we've got the segment at the start, end and on corners and filling in between, let's finish our tour of the linear generator by adding geometry that's spaced at regular intervals along the path. We'll clone one of the existing segments and pick the evenly geometry from the scene. Wire it to the evenly input, and the geometry is added to the spline, but far too close together. So as you know by now, we can change this by going to the Rules tab and find the evenly settings so that we can go through these parameters one at a time. So first of all, and most obvious, distance allows you to control the spacing between the evenly segments. And the adjust to end parameter is measured as a percentage of the distance's size, and it determines the threshold at which a new evenly segment is added. The justify option, which is enabled by default, adjusts only the first and the last gap to make the evenly segments fit within the spline. The other remaining spaces are always exactly measured at the distance value. An alternative mode is called adaptive. In this mode, all of the spaces are subtly resized to fit the evenly spacing along the path. All sizes will be the same, although be aware that this doesn't take into consideration the size of the start, end or corners. In adaptive mode, you actually have three other options. You can either force an evenly number of divisions, as you can see here, or you can force an odd number of divisions, or you can leave it at the default and use any number of divisions as the length of the section determines to be most appropriate. Finally, you can also turn off justify and adaptive completely, in which case the evenly segments are measured precisely, starting from the beginning of the spline and counting along the path. Only the final section will be a different size. In this mode, you can also change the direction that these are calculated using the reverse option. And that completes this basic style. Of course, this would be much quicker to create in a real production setting, but we've taken the time to go over nearly all of the key rules that determine how a linear array is constructed. Before we finish with this tutorial, let's just take a quick look at a couple of the other useful generator settings. First of all, switch over to the Limits tab and you'll find two padding settings. These allow you to offset the start and the end of the array, basically shortening it by a set distance. There's also an option here to limit the generator by a material ID assigned to the spline. To illustrate, I'll change the material IDs on the spline section. Now, if I enable the limit by material ID option, I can choose to limit to just one of those IDs, or even use a comma-separated list to target several. Now if we switch to the General tab, we can find even more handy settings. Starting at the top, we have the reverse option, which, well, it reverses the path, but without you having to change the base spline manually. Cap holes will fill any part of the array that gets sliced, so you don't get open ends. X offset translates the array on the X axis. Y offset, on the other hand, expands the spline to one side or the other, and this setting is particularly interesting when it's used in conjunction with the mirror checkbox found above. When this is active, you're actually creating two versions of the array, one on either side of the spline. If necessary, you also have the option to flip either one or both of the arrays as required. Continuing down, Z offset does pretty much what you'd imagine. It translates the whole array on the Z axis. Finally, you can rotate the array using the path as a pivot. Well, that's a lot to take in, and I think we'll call that a day for this tutorial. We've covered some of the most important settings found in the L1S generator and explored how you can create a basic style. But also, hopefully more crucially, as you work with RailClone, you'll really understand why you're using those settings. In the next part of this series, we'll finish this model and explore how operator nodes can be used to randomize, select, sequence and group geometry for even more sophisticated styles. See you there.